Okay, Assalamualaikum class. So we continue chapter 6 part 5. We go to the IMUL instruction. So the format of the instructions, so we can write IMUL and then source. Okay, so our mnemonic is IMUL and we can write the operand either register or memory. Okay, the operation is IMUL is sign numbers. Okay, and then the operation, it can be in size of byte or word, same as mul. And then the operation is fixed, the result will be saved in AX, and the operation is multiplication between AL and the operand. So that is the size in byte. 8 bit multiply with 8 bit, we get the result 16 bit. And if the operand is a word size, okay, so it will save in DX, AX 32 bit. And the operation is multiply between AX and the operand. 16 bit multiply with 16 bit, we get 32 bit. Okay, and then look at the flag. Okay, C and O flag. Okay, carry and overflow flag equal to 0 when result fits into operand of IMUL. Okay, so its difference, it means that if the result is fit into operand of IMUL, so it will be equal to 0. Okay, and the rest are just a random value. Okay, so we will use this instruction for the example. Okay, so we have instruction move AL -2. We need the calculator. So -2. -2 is equal to FE. Okay, so AL will have the value FE. Okay, and then BL, move BL -4. So BL will have the value -4. So -4 is equal to FC. FC. So we do the multiplication. -2 multiply with -4. Oh, wrong calculator. Okay, so -4 we multiply with -2, and then the result is hexa 8. Okay, so IMUL, it will save in AX. Okay, because the size is byte. Okay, the operation is byte. AL is 8 bit and our operand is 8 bit. And then it will save in AX. So AX will have 0008. And it fixed multiplication is fit in the size. So we just put carry flag and overflow flag equal to 0. So just the rest copy. Okay, this is actually change. Okay, FE 000000 FC. Okay, so now you get your final result. Okay, next we go to the division. So the format is DIV and source. So our operand, it can be register or memory. Okay, so the division for DIV instruction, it just involves unsigned value. Okay, and then if the operand is byte, so we should divide 16-bit AX divide by the operand 8-bit. And then it will save the quotient is in AL and the remainder in AH. So if our operand is word, okay, so we will do the operation division of DX AX 32-bit multiply with 16-bit and save in AX. So the quotient is in AX and the remainder in DX. So we will try to use this instruction for our programming and look at the flags. So the flags is not affected, it just give the random value. So let's say this is our program. So first our instruction move AX 203. So 203 is equal to CB. So AX will have 0, 0, CB. And then we have move BL 4. So BL will have 0, 4. And the last instruction is DIV BL. The division between AX, okay, and BL. Okay, so go back to our instruction set. So the AX will divide with operand and will save in AL. Okay, so AL will change. Okay, here will change depend on the values 0, 0 CB divided by 0, 4. Okay, so I will use a calculator with a decimal value 203. We will divide by 4. So we will have 50. 50 multiply with 4 equal to 200. And then we have the remainder is 3. Okay, so AL, we will have 50. 50. Okay, clear. 50 in hexa is 32. Okay, this is 32. And the remainder save in AH. So AH will have 0, 3. Okay, this is the quotient and this is the remainder. So the rest maintain. Okay, that is for the DIV instruction. And then we go to the IDIV instruction. So it will involve the signed numbers and the operation. For the byte instruction, AX will be divided with the operand. Operand is in byte. And it will save in AL. And AH will be the remainder. Or otherwise, if you use a word size, DX, AX will divide with the operand. And the quotient will be saved in AX while the remainder in DX. So same for the IDIV, flags are not affected, it just the random value. So we will use this example for the instruction, for the programming. Okay, so now we have AX with value negative 203. Okay, we have 203 negative. So we will have FF 35. Okay, FF 35 in AX. Okay, and then BL equal to 4, 0, 4. And then IDIV, what happened? So the operation AX divided by operand and then save in AL. Okay, just now we have 203. So we will get negative, right? Supposed to be negative 50, right? Just take the same value. Okay, we have 203 divided by 4. Just now we have 50. 50 multiply with 4, we have 200. So 50, however, the value in negative, negative 50. So we have FFCE. Okay, however, AL will have CE. The value will have CE. And okay, for the remainder, because this is a negative number, so we just have this one is negative 50. So now we have the remainder supposed to be in negative also. We have negative 3. So negative 3 will be equal to FD. Okay. So the rest maintain with the latest value. Okay. Then we will continue to the lab 4.